Hi students, good morning. Today I am continuing the lesson gravitation and in the today's class I am explaining Newton's universal law of gravitation. The Newton's universal law of gravitation states that the force of attraction between the two objects of different masses is directly proportional to product of their masses and inversely proportional to square of the distance between them. And this is to be derived like this. Here I have taken an object of mass m, object A of mass m, and object B of mass m, small m. And according to the Newton's law of gravitation, the force of attraction between the object A and object B is directly proportional to the product of their masses, capital M and small m, and inversely proportional to the square of the distance between them, that is 1 by d square. The distance of separation between the object A and object B is d, that is f is proportional to 1 by d square. And from equation 1 and 2, f is proportional to m into m by d square. And now I want to remove the proportionality sign, and f is equal to g into m by d square, where this g is a gravitational constant. This capital G is a gravitational constant, and this is what the expression for the force of attraction between the two objects of different masses, that it is f is equal to g m by d square. And if I want to derive the expression for capital G, that is the gravitational constant, then capital G is equal to f d square divided by m into m, and the value of the gravitational constant capital G is equal to 6.675 Newton meter square divided by Newton meter square by kg square, or kg raised to minus 2. This is what the SI unit of the gravitational constant. So this is all about the Newton's universal law of gravitation, and this is how Newton explained and proved that in the universe any two objects of different masses and separated by the certain distance, they attract with each other, and after all they are attracted by the gravitational force of the earth. So this is the from this universal law of gravitation, certain illustrations like when we make to fall a piece of paper from a certain height, and a stone from the same height, the stone comes to the ground level very fastly, and the paper takes a lot of time to come to the ground. This is the reason. What is the reason behind that? It is whatever the mass of the paper is very less in compared to the mass of the stone. That's why even though the height is same, the stone comes to the ground very fastly in compared to the piece of the paper. So this illustration is to be proved according to Newton's universal law of gravitation. There, the reason we got from the difference of the masses. That's why gravitational force is directly proportional to the product of the masses. Mass of the object, and that is also to be taken into consideration. Mass of the object, that is also plays an important role. And after all that, the distance of separation, that is also taken into consideration while studying the gravitational force. And this is the main question, so that of 3 marks that comes in the examination, to state the Newton's universal law of gravitation and derive the expression for G. And what the G here is a gravitational constant, capital G here is a gravitational constant. The value of the capital G is 6.675 Newton meter square per kg square. This is the SI unit of gravitational constant. So this you have, whatever the explanation, you have to write it down in the fair notebook, and you should be perfect with the statement and the derivation. And whatever the SI unit of capital G, gravitation constant, so this you have to by hand, this value and the SI unit. So this is to be by hand. Okay, and some numericals will comes on this formula. So that it is F is equal to G m into m by d square. So on this formula, the numericals will come. Okay, where here in this the G is a constant, the value is this, and among these three physical quantities, two will be given. Uh, among the capital M, small m, and d square, and four, altogether four physical quantities, three will be given, and the fourth one has to be calculated. Okay, so this is how all the explanations regarding the universal law of gravitation. With this, I will stop my today's class, and whatever the remaining part of the lesson gravitation, I will take in my tomorrow class. Thank you.